They call it a Type 6 civilization. It's the final level of a futuristic scale that measures how advanced a civilization is. It's called the Kardashev scale. But who made this scale and why? And yeah, how does our human civilization rank on it? We owe the scale to Nikolai Kardashev. He was an astrophysicist and one of the best radio astronomers of the past century. He got interested in astronomy at an early age. The future scientist worked hard and earned his PhD in 1965. Then he published an academic paper that introduced the scale with his name. Fellow astronomers got interested and expanded Kardashev's scale. At first, the scale only had 3 types of civilizations. One of the people that modified the scale was Carl Sagan, the famous American science writer. The key word to understanding the Kardashev scale is energy. Possible societies from other planets are measured by the amount of energy their technology uses. The more energy a civilization is able to harness, the more powerful the signal it can send. This means we would be able to detect them first. The principle is quite simple. Imagine you were stranded on a desert island. If you manage to light a fire, there's a high chance a plane or a ship will spot you. But imagine you had a signal flare. It would go high in the air, so it would be easier for the search party to find you. Kardashev's scale measured transmission distance in theory. Think of this radio signal as the flare I've mentioned. The most technologically advanced civilization would be able to send the signal the furthest. The more energy a proposed civilization had, the more powerful it was. The famous astronomer decided to rank civilizations in this way. A Type 1 civilization is also called a planetary civilization. A suitable name, as this civilization only has the capacity to harness energy from its home planet. This includes the energy that reaches the planet, such as sunlight. Another form of energy is one the civilization can produce itself. Think of power plants, wind farms, and hydro plants. Sounds a lot like Earth, doesn't it? Yeah, not quite. You see, we are not even a proper Type 1 civilization. Carl Sagan ranked Earth as 0.72, not a full 1. In comes Michio Kaku to explain. This theoretical physicist is one of the best-known popularizers of science today. In his mind, a Type 1 civilization should be able to control the elements, such as volcanic eruptions and the weather. This also includes those nasty shakings of the Earth. Humanity can't even predict these, let alone control them. Ocean cities are another example of technological achievement. For now, underwater cities are something that we can only see in movies. That's why Michio Kaku believes that Earth won't reach Type 1 civilization for at least a century or two. This stage in the development of civilization includes the complete use of resources on the planet. From the energy of the sun to the minerals hidden underground. Then this society would be kinda ready to upgrade. A Type 2 civilization would expand its search for energy beyond the home planet. That's why this type is called an interplanetary civilization. In terms of scale, this would mean using 10 billion times more energy than a Type 1 society. Sagan made this calculation. It would involve more than collecting the sun's energy using solar panels. Yes, I'm talking about going directly to the source. In theory, the best way to achieve this is to use a Dyson sphere. This is an engineering project on a massive scale. The idea is to encircle a star, like our Sun, with orbiting platforms that would form a sphere. The goal is to harness the star's energy and use the platforms as living space. Sounds out of this world, right? Well, that's because it is. The megastructure got its name from the American theoretical physicist Freeman Dyson, who first proposed it back in the 60s. He believed that the sphere would be the way possible extraterrestrial civilization would generate energy. If we spot one in outer space, there is definitely an advanced society behind it. For humans, the Dyson sphere might become a reality in 1 or 2,000 years. That's how far we are from becoming a fully fledged Type 2 civilization. That's a long time. I mean, 1,000 years ago, we were in the Viking Age, nowhere near the world we live in today. But wait till you hear how long it would take us to reach Type 3, a full 100,000 years. This civilization would go beyond its home and other planets. It would master entire galaxies. This far into the future, who knows if humanity would still exist? At least in the format we know of it today, robots would probably be constructing Dyson spheres across faraway galaxies. Are you tired of getting stuck in traffic jams on your way to work every day? The laws of physics state that the fastest you can get there is at the speed of light. To us, this speed is astounding. But for future civilizations, this would be slow. They would need to warp space and time to go faster. Yes, exactly like the warp drive from Star Trek. Or they could develop wormhole teleportation. We are barely a Type 1 civilization, so we can only guess what a new technology a Type 3 will use to travel across the universe. This advanced society would probably be able to extract energy from black holes. Another possibility is that they could manipulate molecules. They would create new materials out of nothing. If such a powerful society exists, humanity should not hope to come in contact with them. So far, we are technologically inferior. Kardashev thought of Type 3 as the most advanced civilization possible. He didn't feel the need to further develop his theory. But other science enthusiasts didn't stop there. They expanded the scale with extra types. In the new scale, a Type 4 would harness the energy of the entire universe. They wouldn't need to live on a planet, but would inhabit black holes. The energy sources they would use are unimaginable to us. These societies would be so advanced that they would use laws of physics humans haven't discovered yet. So, is there anything left for a Type 5 civilization after Type 4 mastered the whole universe? Yep. Because who said there had to be just one universe? Their society would source power from multiple universes, that is, multiverses. At Type 6, a civilization wouldn't have to worry about energy. It would be so advanced that it could create universes. These beings would probably be able to control space and time. They would have the status of a deity. At some point, this civilization would probably become one entity, a supreme single mind that would control all existence. It would be the only one to understand what a more advanced type of civilization would look like. We Earthlings don't stand a chance of grasping the concept. But it's not all bad news for the inhabitants of the blue planet. We have the possibility to move up the scale. Kardashev made the scale to measure civilizations beyond Earth. He gave our planet only as a starting point. We are advancing slowly, but every new power plant humans build is a step closer to a proper Type 1. Scientists estimate that every time we increase our total energy supply by a quarter, we advance 0.01% on the scale. This occurs every 5 years or so. Not a huge push forward, but we're getting there. The key to reaching Type 1 and beyond is renewable energy. Every now and then, scientists discover a new source of energy. Geothermal energy and offshore wind power are just a couple of examples. Each time we find a new way to power our world, we get a step closer to a planetary civilization. So far, the energy of the sun seems the most promising. There are already solar panels at the International Space Station.
So, you decide to give a ball a good kick across the floor. It goes flying. But here's the cool part. For those few seconds it's soaring through the air, you're not just witnessing the usual 3-dimension of height, width, and depth. But there's another dimension in play. Time. Now, I know what you're thinking. How on earth can we see time? Well, we can't exactly see time itself, but we can observe its effects. And what better way to do that than by watching the ball's movements? As it travels through space, we get a glimpse of that progression of time. It's like a sneak peek into the 4th dimension. But when we dive into discussions about space-time, we often throw in an extra dimension, the 5th one. Think of it as a micro-dimension, not as obvious as the other 4. You won't spot it just by kicking a ball around. In the epic movie Interstellar, there's this whole thing about these 5th dimension beings secretly helping out the main characters. These beings are from another realm or something, and they hook them up with a sweet spaceship and a super convenient wormhole for intergalactic travel. At the end of the film, They go through a black hole and end up in this crazy library of infinite knowledge. And those mysterious beings are actually McConaughey himself. Before we get too deep, let's start with the building blocks of everything in this universe. Point. Yep, that tiny little dot holds the key to it all. Let's label it as 0 dimension. Dimension number 1 is just a line, a super skinny line stretching from point A to point B, like a tightrope walker defying gravity. It's like a ghostly concept that we can understand, but in reality, our world is all about things we can touch and see. Even the tiniest stuff around us has some length and width, unlike this elusive line. Dimension number 2 is a plane. When you take a line and give it some width, you got yourself a plane. It's like a flat surface that you can view head-on. Think floors, ceilings, tabletops, TV screens, and movie screens. As easy as it is to imagine a plane, it just can't quite exist in our reality. Yep, even sheets of paper have some depth to them. However, you've seen the second dimension if you've ever watched any pre-internet cartoon. Typically, all the vintage cartoons out there are two-dimensional. Now, welcome dimension number 3, which is space. It's the one we call our own. When you add a little something to a line, it magically transforms into a plane. And guess what? When you blow it up from a different angle, that plane becomes an object in our super cool world. We're all about length, width, and depth here. They're totally our jam. Time is dimension number 4. Close your eyes and imagine yourself right now, in this very moment. Now picture yourself 2 minutes ago. Or how about 2 days ago? Wait, let's take it up a notch. 2 years ago. And what about 2 centuries ago? Now here's where things get funky. Imagine all these versions of yourself from different points in time, connected along a timeline. It's like you're physically linked to each of these variations of yourself. It may sound complicated, but in reality, the jump from the 3rd dimension to the 4th dimension is just like the previous jumps we've made. Imagine you're looking at a line. If you change your perspective a bit, that line becomes a whole plane. It's like a revelation that the super skinny line you saw before was just one part of a bigger physical object, its length to be exact. Now let's take it a step further. When you shift your gaze from the plane to an everyday object or even a person, that plane becomes like a frozen snapshot of that thing. It's just one side of it, without any depth or perspective. But if you physically turn around and look at that single face, you're entering Dimension 3. If you repeat this process once again, you'll find yourself in Dimension 4. Now you're not just looking at an object from its 3 special dimensions, but you're seeing it as one face of a timeline. It's like realizing that any object we know is just one part of a whole timeline. If you could step outside of time and zip across that timeline, you'd witness all the different versions of that object, its past, present, and future. Like flipping through a crazy flipbook. It's like having all those individual frames strung together forever in both directions. And what about dimension number 5? This is where we find McConaughey in that bookcase scene. Get ready to leave the 4th dimension behind and dive into a world of endless possibilities. You see, those physical manifestations we witness are just one side of the story. They represent the realm of possibility. Now imagine a timeline as a bunch of possibilities stemming from a single moment. Let's use your birth as an example. Each moment in your life is like a face on a never-ending you from the 4th dimension's perspective. Now picture this timeline as just one face on a crazy object made up of countless other timelines. Each line represents all the different moments and faces that could have happened after your birth. It's like the 5th dimension's view of you. Back in 1905, Albert Einstein dropped some pretty cool knowledge on us with his special theory of relativity. He revealed that space and time are all tied together by the speed limit of light. So technically, our universe has 4 dimensions of space-time. But for our everyday lives, we like to keep things simple and think of the universe as having 3 dimensions of space. You know, north, south, east, west, up, down, and 1 dimension of time, which is past and future. Easy peasy. In the 1920s, a couple of genius physicists named Oscar Klein and Theodore Kaluza were like, hey, what if there's a fifth dimension of space? They got this wild idea from Einstein's theory of relativity, which showed that mass can warp space-time. So they wondered, could this extra dimension explain another force called the electromagnetic force? Turns out, it totally could. But here's the catch. The electromagnetic force is way stronger than gravity, like 1,040 times stronger. So for this extra dimension to work its magic, it had to be super tiny. We're talking smaller than an atom, like microscopic small, so small that we wouldn't even notice it. Picture a particle, like an electron, zipping through space and doing loop-de-loops around this fifth dimension, like a little hamster on a wheel. Kaluza and Klein's five-dimensional theory got hit hard when two more fundamental forces were discovered in the atomic nucleus: the strong and weak nuclear forces. But many other scientists who believe in string theory brought back the idea of extra dimensions explaining forces, and it's been about half a century since then. According to this theory, the universe's fundamental building blocks are not particles, but these super tiny strings made of mass energy. These strings do their thing by vibrating in a 10-dimensional space-time, with 6 of those dimensions rolled up way smaller than an atom. String theory suggests that our universe might be like a 3-dimensional island, or a brain just floating around in this massive 10-dimensional space-time. This could explain why gravity is so ridiculously weak compared to the other 3 fundamental forces. The idea is that while the forces are stuck on the brain, gravity sneaks out into those 6 extra space dimensions, making it super diluted on the brain. In 1999, Lisa Randall and Raman Sundram had a mind-bending idea. They suggested that there could be a bigger fifth dimension, all curved in a way that we can't even see. And this extra dimension might solve one of the biggest mysteries of the cosmos: dark matter. You know, that invisible stuff that outweighs all the visible stars and galaxies by 6 times? Yeah, it might just be hiding in that mysterious extra dimension.
Now, sure, science and technology will continue to evolve, but there are some inventions we just have to forget about. Not because we don't have the resources for them, but simply because they are physically impossible. On that note, let's talk about human teleportation, a cool concept you may have seen in the movies. Quantum teleportation has been demonstrated in labs, where scientists have managed to create a connection between entangled photons over long distances. But let's be real, that's a far cry from teleporting an entire human being. Plus, the teleportation in the Star Trek universe, for instance, involves something called destructive copying, which means the original person gets obliterated. Ouch. So even if teleportation were somehow possible, it would be basically like stepping into an annihilation machine. On top of that, the sheer physical and energy requirements for teleportation are mind-boggling. Just imagine a system that can instantly scan, record, and transmit every single bit of information that makes up a human body. And then, it has to compile that person at the destination without even slightly messing up a single molecule. It's a whole lot easier to send someone a PDF. So, as much as teleportation sounds awesome, it's not something we can realistically achieve. The technology and energy needed for such a feat are way beyond our current capabilities. Maybe someday in the future, but for now, teleporting ourselves from one place to another remains firmly in the realm of science fiction. And so, mass transportation needn't be worried about becoming obsolete. Human teleportation isn't the only thing on our impossible things list. Let's dive into the concept of time travel too. Thanks to the genius of Albert Einstein, we've come to realize that time travel is actually a thing, at least technically. Einstein's theories proposed the existence of these nifty things called wormholes, which could connect different parts of space and time. In other words, they might just be the key to creating a legit time machine. Now, here comes the tricky part. According to some super smart physicists, if we ever want to build a time machine, we'd have to figure out a way to harness the energy of an entire star or a massive black hole. And that's not all. There's an even bigger challenge. We'd also need to stabilize the wormhole and make sure that the entrance, or the place where we step into the wormhole, stays open for our return trip. Because, let's face it, nobody wants to go back in time only to find themselves stuck there forever. Unless you could buy Apple stock right at the beginning. Imagine this. We've all seen those cool spaceships in movies that have these awesome protective layers, right? Well, it's not completely out of the question that someday our spaceships could have a similar setup. They could be surrounded by a special layer made of charged plasma or a super strong electromagnetic force. Now here's where things get a bit tricky. When it comes to personal force fields, it's a whole different story. You see, a force field's main job is to either soak up or bounce back a whole lot of energy coming at it. In order to do that, it has to push out with an equal or even stronger force to stop the energy from getting through. Now, if we're talking about a force field just for one person, things get a bit more complicated. The only cosmic force that could potentially work for a personal force field is electromagnetism. But here's the thing. Electromagnetic force only works on charged objects. And guess what? Humans are electrically neutral, which means we don't have a charge to play with. So even if we somehow manage to create a gadget that could envelop a person in a mighty force field, there's no guarantee that the person inside wouldn't get zapped. Making the force field work in all directions would be a real challenge. So, while it's a super cool idea to have our own personal force fields, it's not as easy as it sounds. Physics and our electrically neutral bodies make it quite the uphill battle. Meanwhile, will we ever be able to upload our minds into supercomputers? Well, not really. Because here's the thing, we can't transfer our consciousness. Most methods of uploading focus on copying our brain's basic information onto a digital platform. But what happens to our consciousness when we're suddenly in two places at once? You end up with a bunch of identical copies of your mind, albeit digital, each one claiming to be the real deal. They're all equally genuine, too. As with human teleportation, does this mean the original will need to be destroyed? Hard to tell at this point. This conundrum is what the specialists call the continuity of consciousness problem, and is causing quite a stir in the philosophical, neuroscientific, and AI communities. Big topic at parties. The thing is, we're still in the dark about the nature of consciousness. We don't have a solid scientific explanation for it yet, so we're stuck in a guessing game. Even if we can't figure out the whole consciousness thing, the idea of uploading our minds is still pretty mind-blowing, though. Just imagine being able to exist in a digital realm, living out all sorts of wild experiences without the limitations of our physical bodies. It's like stepping into a whole new world, or through the looking glass. Of course, there are plenty of ethical considerations to ponder. What happens to our sense of self? Will we still feel like us in the digital realm? And what about the copies? Are they just as valid as the original? It's definitely a complex web of questions that might never have definitive answers. There are some things that will never happen, unfortunately, even when it comes to space travel. Sure, it can be a mind-boggling experience, especially when it comes to the whole idea of zero gravity. It's something that many people tend to overlook or misunderstand. The truth is, you can never fully escape the clutches of gravity, no matter where you are in the vast expanse of the universe. However, there's still a way to achieve that weightless sensation we often associate with being in space. Now, even in the depths of space, various gravitational forces are at play, exerted by celestial bodies like the moon, the sun, and the countless stars out there. But here's the thing. If you can match your acceleration with your surroundings, you can create the illusion of floating. This is precisely why astronauts undergo specific training. A unique aircraft takes a dive into freefall, giving them a taste of weightlessness for a brief period of time. Now picture this, being weightless, completely free from the pull of gravity. It's an experience like no other, and those who have had the pleasure describe it as utterly surreal. In a so-called zero-G environment, it's impossible to distinguish between floating and actually plummeting towards the Earth when you close your eyes. That's why aircraft training plays a crucial role in preparing astronauts for the real deal. Now, don't get me wrong, I totally appreciate all the theories about space colonization. But let's get real here. We're not going to be cruising through space on a gigantic interstellar vessel anytime soon. You know those generation ships they talk about? Well, it's a pretty cool concept, but let's break it down in a more down-to-earth way. The idea behind these generation ships is to create a self-sustaining miniature version of Earth that can support a group of brave space explorers on their long journey to another solar system. Here's the catch, though. The distances between solar systems are mind-bogglingly vast, and that poses a major challenge. We're talking about some serious logistical problems when it comes to resources and materials on a ship that has to sustain an entire colony. We obviously can't afford to be wasteful on a mission like that. That's where the concept of suspended animation swoops in. What this means is that we'll have to freeze everyone up for the journey, just until they reach the desired destination, of course. This also covers the problem of raising a family on a starship. The odds of someone agreeing to spend generations upon generations hurtling through space are pretty low. However, even if suspended animation sounds like a better solution, we are still far from figuring out how to maintain people in that state for longer periods of time. For the time being, tests have only shown this might work for mere minutes.
Black holes pull everything inside they see. You'd better not approach the asteroid belt between Mars and Jupiter. It's extremely hazardous. The Sun is yellow. All these statements seem to be universally believed, but are they true? No. Let me tell you the real truth. When you look at the images of the Sun, it may seem that our star is on fire. But in reality, the process of burning needs three components: heat, fuel, and oxygen. The Sun does have some fuel since it's mostly made up of hydrogen and helium, and the former is highly flammable. The star also produces enormous amounts of heat energy, but there's no oxygen in space. So, as you see, the fire triangle remains incomplete. So, instead, the heat and light the Sun generates are the result of thermonuclear fusion. Now, about those black holes. You probably know that their gravitational pull is so powerful that not even light can escape their clutches. In other words, you might be imagining a black hole as a giant, cosmic vacuum cleaner clearing vast areas of space. But in reality, black holes behave just like any other supermassive object in the universe. The speed you need to escape from the gravitational pull of an object, be it a black hole or a planet, is known as the escape velocity. If we take our Sun, which has a relatively modest gravitational pull, you'd need to travel at a speed of 384 miles per second to get away from it. If your spaceship couldn't achieve this speed, you'd fall back down to the surface of the Sun. But at the event horizon, aka the point of no return of a black hole, even something traveling at the speed of light wouldn't be fast enough to get away. And still, if there was an object that could move more quickly than the speed of light, it would most likely manage to escape, even if it had already crossed the event horizon. The asteroid belt between Mars and Jupiter isn't a region of hectically moving and constantly colliding large rocks. If you ever found yourself there, you'd see how empty and calm it is. The asteroids are so far apart from each other that the chances of collision are laughably small. If you were traveling by spaceship, its radar would easily detect asteroids and would help you avoid them. The vacuum of space is not always cold. It depends on where you measure its temperature. If it's a totally dark, freezing cold part of our universe, the vacuum of space can get as cold as minus 454 degrees Fahrenheit. But if you travel closer to the Sun, your thermometer will show a boiling 250 degrees Fahrenheit. The Sun seems to be yellow, which is confirmed by the photos of our star. But it's just an illusion. The Sun produces all wavelengths of visible light. That's why its true color is white. But when sunlight travels through Earth's atmosphere, it changes. The wavelengths of light at the blue end of the spectrum are way shorter than those at the red, That's why collisions with particles in the air are more likely. That's why during the day, blue light scatters pretty high in the atmosphere, hence the trademark blue color of the sky. That's also the reason why the sun looks yellow. Comets' tails always show which way they're heading, right? Well, it's not that easy. These space travelers are essentially lumps of dirty ice. While approaching the sun, they heat up, releasing dust and gas. If it was happening on Earth, we could expect the resulting tail to point backwards. But in space, there's no air. And since comets are shaped and blown by solar winds and radiation pressure, their tails always point away from the sun. It happens like this. High-energy ultraviolet light collides with the evaporating gas of the comet, taking away electrons and producing charged ions. They get caught up in magnetic field lines and dash away from the sun in a beautiful blue ion tail. Mount Everest is considered to be the tallest mountain on Earth, but it's only true if we speak about its height above sea level. If we take base to summit height, the tallest peak on the planet is Mauna Kea on the Hawaiian Islands. Everest rises 29,035 feet above sea level. For Mauna Kea, this number is a mere 13,800 feet, but a large part of it is submerged, and the mountain's total height is 33,500 feet. That's almost taller than Everest. Our planet does not orbit around the sun. What's going on is the sun, Earth, and all other planets moving around the common center of mass of the solar system. It's indeed very close to the sun, but not exactly at the center of the star. When people think of ringed planets, the first thing that comes to their mind is Saturn. But this gas giant isn't the only planet with rings in the solar system. Jupiter, Uranus, and Neptune all have their own sets of rings, but they're much thinner and not so visible from Earth. But even though Saturn can boast the most impressive rings out there, Neptune's moon Triton may be torn apart by tidal forces in the next 100 million years. If it happens, Neptune will have a dramatic new ring system of its own. Despite a common misconception, Earth is not quite round. Isaac Newton first suggested that Earth was not a perfect sphere in 1687. And like many of his other ideas, it turned out to be true. Basically, we live on a squashed soccer ball. The world is flatter at the top and bottom and bulges out a bit in the middle. But the difference isn't all that great, so this belly is really tiny considering Earth's size. This unusual shape is caused by the way Earth spins. The moon doesn't really have a dark side. This natural satellite is tidally locked with Earth. That's why we always just see one side of it. There's a misconception that volcanism makes tectonic plates move by pushing them apart. In fact, it's quite the opposite. Tectonic plates' older edges are denser and cooler. This eventually causes them to sink deeper into the mantle of our planet. When two tectonic plates get pulled apart during this process, ocean ridges appear. It also results in volcanism. It's not the moon's gravity that causes the tides. Earth's natural satellite does pull on the water in the oceans, but this tug is more than 10 million times weaker than the gravitational pull of our planet. What creates the tidal force is the gravity interplay between Earth, the moon, and the sun. Plus, it's more of a push than a pull. Is Mercury the hottest planet in the solar system? It seems logical. Mercury is the closest to the sun. Therefore, its surface temperature must be higher than that of all of the other planets. But in reality, the hottest planet in the solar system is Venus, despite the fact that it's more than 30 million miles further away from the sun than its neighbor. The average temperature on Mercury is around 333 degrees Fahrenheit, whereas it can reach 867 degrees Fahrenheit on Venus. The reason for this is Venus's atmosphere. Mercury has practically no atmosphere. whereas Venus has a very thick one made up almost entirely of carbon dioxide. This creates a strong greenhouse effect, trapping all the sun's heat and making Venus incredibly hot. There's another myth that claims that a human would explode in space without a spacesuit. In reality, our skin is flexible enough to keep all of our internal organs in place. But in the absence of external pressure in space, the blood in the human body would boil. As a result, the body would expand in size, but it definitely wouldn't explode. And the main problem for a person without a spacesuit would be the lack of oxygen.
Spooky tales don't just happen in weird forests or shady castles. They can also take place in space. On that note, let's dive into a galaxy of eerie stories that will leave you shivering under your blanket. Our first tale introduces us to an astronaut legend who retired from NASA. He wasn't just any astronaut, but the one who had flown on 6 space missions. This man had been to space more than most of us had been on vacations. Additionally, he was a proud owner of 6 academic degrees. Ooh. When a man with such an impressive resume makes a claim, it's hard to brush it off. He reported seeing an 8-foot-long white entity, looking quite similar to a snake, wobbling around in space. While it's tempting to dismiss this as a lost hose or some other equipment, our good astronaut stood his ground. He insisted it was some kind of weird creature, something he had encountered not once but twice on his space missions. His staunch belief in life outside our planet is enough to send shivers down anyone's spine. Is space filled with otherworldly snakes? Our next story starts with a quick astronomy lesson. Space is utterly silent. That's because sound can't travel through the vacuum of space. Astronaut suits need to have special communication devices just so they can talk with their peers and people back home. So imagine this bone-chilling fear experienced by another astronaut as he was sitting alone in a spacecraft. During that time, he kept hearing this knocking sound, like someone hammering on a metal bucket with a wooden object. Unable to determine if the sound was coming from within or outside his spacecraft, he did the only thing he could: check the porthole. Alas, nothing. He couldn't find anything that would explain this weird knocking. Despite efforts to replicate the sound back on Earth, he couldn't quite nail it. The plot thickens, though, as other fellow astronauts also reported hearing similar sounds during their space voyages in 2005 and 2008. Needless to say, they haven't figured it out. Let's turn our focus to an idea that's been floating around ever since the first moon landing. Neil Armstrong and Buzz Aldrin's steps on the moon marked a pivotal point in human history, but some theories suggest a more sinister backdrop. One such thought was that the moon is essentially a watchtower, used by non-human creatures living in space. This outlandish claim is rooted in the notion that Armstrong, upon reaching the moon, spotted 2 unidentified spacecraft parked up like cars at a viewpoint. According to this lore, these unidentified objects were enormous and seemed to be peering down at Earth. The backdrop to this story is the curious 2-minute silence from NASA's transmission during the Apollo 11 mission. So, did Armstrong actually spot some sort of life form during that period? We'll file that one under not likely. Although we've established that space is silent, several other astronauts have reported hearing peculiar sounds while floating in the cosmos. The Apollo 10 crew, who were running test operations for the upcoming Apollo 11 mission, faced a bizarre occurrence at the same time. As they orbited the moon, astronauts Stafford, Young, and Cernan began hearing what they described as strange whistling music. The spooky sound lasted for nearly an hour and left the astronauts rattled. Upon their return to Earth, they debated whether to share this haunting experience with the rest of the world and NASA. Later, astronaut Michael Collins of the Apollo 11 mission confessed to hearing similar tunes while orbiting the moon. A U.S. Space Agency engineer suggested the sounds were likely radio interference. However, an astronaut from the Apollo 15 mission disagreed, deepening the mystery surrounding these cosmic tunes. Then there's the story of Alan Bean, the 4th man to walk on the lunar surface during the Apollo 12 mission. He reported spotting a shiny object shaped like a shoe on the moon's horizon. There's been no concrete explanation for what Beam saw, and with his passing, the enigmatic lunar glimmer may forever remain a mystery. When someone brings up the topic of a spaceship, the typical image that floats in the mind is that of a round disc-like object hovering mysteriously in the pitch-black sky. However, when two astronauts of the Gemini 4 space mission recount their encounters, the picture painted is a tad bit different. On the second day of their grand voyage in space, one of the two astronauts spotted something utterly peculiar outside their spacecraft. It was something he just couldn't pin a name to. They were coasting along aimlessly, with his colleague catching up on some sleep, when he caught sight of this strange rotating object off in the distance. Not missing a beat, he reached for his camera and began snapping photos of what he likened to a soda can with a sleek pencil-esque appendage protruding from it. Unfortunately, though, the photos turned blurry and poorly lit. He was in a hurry and quite rattled after all. The astronaut attributed the sudden loss of the object to the glaring sunlight that filled the window. As the youngest of the original group of astronauts of Project Mercury, America's initial human space program, Gordon Cooper piloted both the Mercury 9 and Gemini 5. With a passion for flight, sparked at an early age, and his qualification as a test pilot in 1956, Cooper's life has been chock full of adventures. Now, among these adventures, Cooper also claims an intriguing encounter with the unknown. During his time in the Air Force, Cooper reported having come across a whole armada of otherworldly spaceships. This may seem like a baseless claim, but in 1963, Cooper reportedly encountered a flying object similar to those from his earlier sighting. The object raced toward him, captivatingly appearing on his aircraft's radar. It does make you wonder why Cooper was such a magnet for these ships, right? Fast forward to 1991, when a decorated cosmonaut who was serving as a flight engineer spotted something completely out of the ordinary. He unintentionally filmed a radiant, peculiar object that was twisting and turning its way through space. The object was cylindrical in shape, and the man's initial thought was that it might be a piece of a spacecraft that had broken off. But the speed and rotation of the object instilled a seed of doubt in the cosmonaut that would never quite leave him. The object was behaving against the laws of physics. Will we ever find out what this object was? Probably not, but it does make you wonder too. In 2009, an American astronaut, who was the commander of the International Space Station along with his crew, reported an encounter with an intriguing set of lights in space. According to him, the lights were arranged in a pattern that formed an upside-down V. The sight of this unexpected spectacle had the astronaut's heart thumping with sheer excitement. He kept his focus on the enigmatic object until it gradually disappeared from his sight. Even later on, the man staunchly believed that what he saw was a genuine visitation from outer space. He also entertains the idea that the object, or creature, he witnessed might have originated from a parallel dimension. This next story stars none other than wasabi. It happened when a brave astronaut was aboard the International Space Station. So, as she was trying to add some of this spicy paste onto her meal, whoops, a little glob made a great escape. It reached the walls of the spaceship, leaving hidden droplets here and there in the module. The aftermath was a spaceship smelling strongly of wasabi, and trust me, that's not a fragrance you would want in your enclosed living space. It took quite some time to air out the wasabi aroma that had stubbornly spread all over the place. Alas, it was too late for NASA to launch an emergency shipment of sushi to the space station. Actually, that last part I made up. Anyway, while we're at it, let's also share a bit about the thrilling, not-so-smooth journey to and from this space station. If you think it's all dreamy, well, you're wrong. One particular spacecraft, for example, was notorious for its intense G-force experience. One NASA astronaut described it in a rather fascinating way. She said it felt like a train wreck, followed by a car crash, and then like tumbling off your bicycle. Well, that sounds like fun. Despite how much we already know about black holes, there are things that are still a mystery. For example, these space monsters seem to gain weight even when there's nothing for them to feed on. This realization might shed light on mysterious dark energy, but I'll talk about that a bit later. Most supermassive black holes lie in the centers of their home galaxies. You can probably say that they sit in the gravitational driver's seat. Meanwhile, hundreds of billions of stars, planets, and moons orbit them. Even though black holes are really, really big, physics makes it almost impossible for them to grow. But we've found one of these space wonders that has swollen to really unimaginable proportions. The black hole I'm talking about is Ton 618, and it's a mind-boggling 66 billion solar masses. The thing is so massive that astronomers had to think of a new term to describe it. They came up with an ultramassive black hole. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a Ton 618. So the question is, how did this ultramassive black hole turn into such a behemoth? You probably know that black holes are made of matter packed together as densely as possible, to the point where gravity gets so powerful that not even light can escape it. And still, it doesn't mean that black holes are some kind of space predator roaming galaxies and munching on everything they come across. Ton 618 still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. What I want to say is that the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try to do it and you'll see. First of all, the material needs to get close enough to be affected by the black hole's gravity. And that's not so easy, considering how vast the universe is and how relatively small in size black holes are. But if something does get close enough, there's no escape. That's true. The force of gravity around the black hole increases dramatically fast. It even creates the effect of spaghettification, when an object gets stretched into thin strands of space pasta due to the influence of gravity. Once spaghettified, the matter then gets pulled into the black hole's orbit and flattened into a swirling and glowing disk of material. Eventually, this matter settles into a nice orbit around the black hole, quite far away from the point of no return, also known as the event horizon. By the way, we can use the event horizon to estimate the size of a black hole. The larger it is, the more massive the black hole you've come across is. Interestingly, getting the matter to cross the event horizon will be the most difficult part if you decide to grow yourself a black hole. You'll need to push the material out of its stable orbit around the black hole and make it fall in. As an example, we can take the Sun and Earth. Despite the star's enormous gravity, our planet doesn't get pulled toward it. And the main reason why the material can cross the event horizon is collision between particles. This way, they gain some energy, which is enough to send them spiraling into the black hole. But what happens afterward? The center of the black hole likely collapses into something called a singularity. That's infinitely dense material crammed into an infinitely tiny point in space. But the main problem here is that singularities are mathematically impossible. That's why some scientists suggest that when this weird stuff happens inside the black hole, its mass gets linked to the expansion of the entire universe. Yep, when it gets weird in space, it gets really weird. Such a coupled black hole is like a rubber band being stretched along with the universe as it expands. And as it stretches, its energy increases. And since mass and energy are proportional, the mass of the black hole increases too. But this new mass creates a pressure that makes the universe expand even more. That's the reason why the universe is expanding faster and faster all the time. But several scientists have suggested that, instead of a singularity, there might be something very different in the heart of the black hole – vacuum energy, which is one form of dark energy. Okay, but what is this dark energy? Everything on Earth and everything people have managed to see in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Around 27% of the universe is dark matter, and almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if, several decades ago, they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant there had to be some enigmatic force counteracting gravity, and it got dubbed dark energy. The European Space Agency's Planck satellite helped astronomers calculate how much dark energy the universe has to contain to explain the way its expansion is constantly speeding up. Scientists have also built models of how many giant stars formed and collapsed into black holes since the beginning of the universe. The conclusion is very exciting. The vacuum energy in these black holes is almost the same as the amount of dark energy that should exist in the universe. The scientists who conducted these experiments don't claim to have found the answer to the mystery of dark energy or to what we could see inside a black hole. But still, their theory is quite plausible. It can be tested with modern computer simulations and new data received from cutting-edge telescopes and other equipment. And now, let's speak a bit about dark matter. What it is and what it consists of. Actually, this is another thing that confuses scientists to no end. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super-dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. It is dark, which means we can rule out visible stars and planets. It also can't be dark clouds of normal matter, otherwise scientists would be able to detect it. Dark matter is not antimatter. Astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic galaxy-sized black holes. There's one theory, though, and it's linked with the hypothetical concept of primordial black holes. Scientists have never got any real proof of their existence, but they think these black holes might be insanely old and quite tiny, by black hole standards, that is. Astronomers believe they could appear several milliseconds after the Big Bang. At that time, stars and galaxies weren't born yet. It means primordial black holes probably witnessed the entire history of the universe. By now, the smallest primordial black holes would have most likely evaporated away, but the bigger ones might still be scattered out there in space. Interestingly, these holes might be so small exactly because they popped up right after the Big Bang. The longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes is incredible. Compare the mass 1,000 times greater than our Sun to that of a jelly bean. Yeah, you get it. So, there's this theory that primordial black holes could actually be dark matter. This idea remained unpopular for decades. But recently, scientists have realized there are many more black holes in the universe than they used to think. And it means the theory might actually work. And the vast and still hidden from us population of Big Bang black holes could not only make up, but be dark matter. After all, astronomers haven't discovered a single dark matter particle yet, even after decades of searching. At the same time, some scientists argue that dark matter can't be tons of multi-sized primordial black holes. They would collide far too often for this to work out. So, if you have a problem with all this stuff, just ask your nearest scientist, "Hey, what's the matter?"
For years, scientists have been struggling to explain bizarre sounds, some repeating, some heard only once, that come from the dark depths of the ocean. From bewildering hums to worrying bloops, the water transmits outlandish acoustic phenomena. One of these mysterious noises got named the upsweep. For the first time, this long train of sounds was registered in 1991 in the Pacific Ocean. One of the most unusual things about this signal is that it keeps changing, as if trying to confuse researchers even more. Like some unearthly howl, it varies from high to low frequencies and then back again, and you can hear it better in the spring and fall than in the winter and summer. Why the upsweep? It's simple. The sound travels from the bottom of the ocean towards its surface, as if sweeping up. Scientists do have a theory explaining this phenomenon: the activity of undersea volcanoes. Hot lava pouring into ice-cold ocean water could theoretically create such noises, but there's no proof found yet. Plus, the sound has been declining since 1991. even though it can still be detected. The bloop is the name given to an ultra-low frequency and incredibly powerful underwater sound that was recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The bloop continued for approximately 1 minute. Having started from a low rumble, it gradually rose in frequency. It also kinda mimicked the noise created by marine animals, but its volume was so great that no living creature known to science could have made it. When the bloop occurred, underwater microphones managed to record it from a distance of 3,000 miles away. Rumor has it that the noise might have something to do with the fictional half-octopus monster Cthulhu, or some other colossal deep-water creature. But if you don't believe in monsters, science has another explanation: iceberg fracturing. The thing is that ice quakes recorded in the Scotia Sea resemble the mysterious bloop a bit too much for it to be a coincidence. The whistle resembles this annoying sound when a kettle of boiling water is telling you it's time to make a cup of tea. But even though it may not be as blood-curdling as some other bizarre ocean sounds, it doesn't make it any less mysterious. Plus, the whistle is very elusive. In 1997, only one underwater microphone was able to pick it up, and therefore, researchers didn't manage to pinpoint the source of the noise. The most likely cause of the sound is an eruption of one of the submarine volcanoes. Have you ever heard of Julia? No, not your neighbor. I'm talking about this otherworldly sound. Listen to it. It was recorded in 1999 by the U.S. National Oceanic and Atmospheric Administration. The source of the sound was most likely a large iceberg that ran aground somewhere in Antarctica. The sound was so loud that it was heard over a huge territory, and its duration was about 2 minutes and 43 seconds. Slow down. That's the name given to a sound recorded in 1997 in the equatorial Pacific Ocean. The sound was called this way because it slowly decreased in frequency over 7 minutes or so. It's been picked out a few more times since it was recorded for the first time. The source of the sound isn't very mysterious. Most likely, it was produced by a massive iceberg that became grounded in Antarctica, or it was caused by moving ice. By that, I mean the friction produced by a large ice sheet moving over land. The loneliest whale sound is often called the 52 Hz whale because the animal that creates it calls at a unique for these creatures frequency. When you listen to this sound, it sounds like a low bass note. At the same time, it's much higher than the normal frequency of the whale call, which rings between 10 and 40 Hz. Interestingly, scientists have been listening to the world's loneliest whale for decades, but haven't managed to figure out its precise location. Nobody knows whether the mammal is male or female, what species it is, or if the animal is still alive. After all, for the last time, its call was recorded in 2004. Earth-shaking booming sounds have been reverberating off some parts of North Carolina for more than 150 years. Called Seneca guns, they're most often heard near the coast. The sounds are so powerful that they often rattle window panes and sometimes vibrate entire buildings. They can last from 1 to almost 10 seconds. Even though scientists haven't cracked this mystery yet, there are some theories. They range from earthquakes to severe distant storms and quarry blasts. But even though the ground trembles every time the phenomenon occurs, no seismic activity coincides with these events. So far, scientists have come to the conclusion that the mysterious sounds happen in the atmosphere, not on or under the surface of our planet. If this theory is true, bolides might be the answer. These extremely bright meteors often explode once they enter Earth's atmosphere. Or Seneca guns might be born in the ocean. Sometimes, when enormous waves collide far away from the shore, you can hear it, even if you're nowhere near the coast. Seneca guns are a type of skyquakes. You don't need to travel to a particular part of the world to hear one of those. mysterious sonic booms ramble from the sky everywhere, from the US to India and Japan. Just like Seneca guns, this sound phenomenon occurs mostly near the coast or a big body of water. Rattling glassware and windows in the nearby houses, skyquakes could be connected with ultra-fast airplanes breaking the sound barrier. But people started hearing the first skyquakes in 1824. The theories trying to explain this phenomenon include sand dunes shifting, meteors entering the atmosphere, distant volcanoes erupting, Earth's crust cracking during earthquakes, and even gas bursting out of underground vents in the sea or lake bottom. In different countries all over the world, people get paralyzed with fear after hearing otherworldly trumpet sounds that seem to be coming from the sky. The inhabitants of the US, Canada, Australia, Germany, and the Philippines have already heard this hair-raising noise since it was first recorded in 2008. These sounds are sometimes called the sound of apocalypse. And although until recently, nobody could understand the origin of the sounds, NASA claims that there is nothing to be afraid of. The noise can be coming from our own planet. Usually, it's quiet and thus inaudible to the human ear. But when it gets louder, the outcome is the very trumpet sounds that scare people all over the world. Bristol hum started in the 1970s when hundreds of Bristol inhabitants began to talk about a bizarre noise audible only at night. The noise was a low-level hum, and nobody could identify or trace the source of the sound. But the strangest thing about the noise was that one day, it stopped as abruptly as it started. But not before people in other towns across Britain reported hearing similar sounds. Some time ago, the mysterious sound returned. In 2015, a group of French scientists claimed that they had solved the mystery of the Bristol hum. They stated that the culprit was ocean waves that made the ocean floor vibrate. But while it was all good and well, it didn't explain why the sound was around for only several years or why it chose to return. If you ever come to the town of Taos in New Mexico, don't let another strange and unexplained phenomenon send you running for the hills. This phenomenon is a faint, low-frequency hum ringing in the desert air and grating on your nerves. Even stranger, only 2% of people who live in Taos hear this noise. But for those who do, it's unstoppable torture. On top of that, everyone describes the sound in a different way, from a quiet whir to an eerie hum or even persistent buzz. And while some people believe that the Taos hum is the result of unusual acoustics, the others suspect a bad case of mass hysteria. No one has located the origin of the hum yet.
We've all heard of the Sahara. Sure you have. It's the largest hot desert on the planet. A sea of sand covering an area larger than the contiguous United States. But have you ever wondered what lies beneath the sand dunes? To answer this question, we must travel deep into the past of our blue planet. Up until some 6,000 years ago, the Sahara was grassland. Humans were around at this time, not me, spreading agriculture around the planet. In the north of Africa, the color green dominated. Plenty of rainfall meant that there were lakes, rivers, pastures, and even forests. A completely different image of the Sahara from the barren landscape of today. But then, the climate started to shift. The region became parched, and the vegetation started disappearing. The wind did the rest. It took away the fine sediment after there were no plant roots to hold the ground together. Give it a couple thousands of years, and you get a familiar image of the Sahara. Sand and rocks stretching as far as the eye can see. But when it comes to volume, only a quarter of the Sahara is actually sand. The yellow sands of the Sahara are just one part of the story. The desert has many other features, such as gravel plains, salt flats, and plateaus. Makes you think if we understand the word desert correctly. For people who study such terrains, geologists, there is only one condition for defining a desert: precipitation. If an area gets little or no rain, then it's considered a desert. The Sahara certainly fits the bill. Its average annual rainfall is just 3 inches. Compare that to the nearly 45 inches a year in New York. When we look at precipitation, this sandy desert is only the third largest in the world. Number 1 and 2 are Antarctica and the Arctic. They are larger than the Sahara by millions of square miles. It sounds odd, but there is more than one type of desert. The first two are polar deserts, while the Sahara is a subtropical desert. But the difference in air temperature are staggering. In Antarctica's interior, temperatures plummet to minus 76 degrees Fahrenheit. Compare that to the highest temperature on record in the Sahara of 136 degrees Fahrenheit. But this desert has a cool side. At night, the temperature is roughly the same as the average yearly temperature in Denmark. This hot and cold roller coaster makes it hard to choose the right outfit when venturing into the Sahara. And what about the sand? How deep is it actually? The depth varies between 70 and 140 feet. That's not too deep. If you put the Statue of Liberty in a tall dune, half of it would still stick out of the sand. Its vast amounts in the Sahara were created by aeolian processes. That's Greek for wind. Over time, it blows and shapes the surface of the earth. In dry areas with sparse vegetation, winds erode the ground much faster. That's what happened in North Africa. Under all that sand is the bedrock and cracked clay. If you started digging, you would find the same everywhere on the planet, with one important difference. There is some type of soil covering the bedrock. This is not the case in the Sahara. Because of the arid climate and a lack of vegetation, sand covers the ground below. Over the course of thousands of years, a lot of interesting finds ended up in the desert sand. For example, there are petrified tree trunks. These are essentially preserved prehistoric trees. They date back to the time when the region was lush green. In some places, the trees of this fossilized forest are at least 65 feet tall. The wood is so well preserved that you can still see the texture and knots. There are even fossilized pine cones. In 1992, scientists found glass fragments in eastern Sahara. These canary yellow glass shards were scattered across hundreds of miles. They didn't belong to an ancient civilization, although ancient Egyptians used them to make jewelry. In fact, the breastplate of King Tut had a beautiful scarab beetle centerpiece made from this desert glass. For a long time, scientists were puzzled about the true origins of these fragments. They finally concluded that the glass was around 29 million years old. It is an impact tape. If that sounds like it has something to do with the word impact, you are correct. These rocks are formed when a meteorite hits the surface of the Earth. This generates a lot of heat. Scientists estimate that the temperature needed to melt this mineral was close to 3,000 degrees Fahrenheit. Apart from the regular fine-grained sand, we also have melted sand in the Sahara. But the desert conceals other unlikely artifacts. Shark teeth are a common find in Morocco, which sits in the western part of the Sahara. What are the fossilized teeth of these marine predators doing in the middle of the desert? This part of the world looked entirely different millions of years ago. There was a sea cutting right through what is now a desert. The Trans-Saharan Seaway ran the length of present-day Algeria and Mali. It was around 165 feet deep. That was enough for all sorts of aquatic animals to inhabit it. Large catfish, sea snakes, and of course sharks lived in the area. British archaeologists even unearthed a turtle shell in Mali in the 1980s. For centuries, there was even an entire city hidden under the desert. Timgad was a Roman outpost constructed by the Emperor Trajan around the year 100 in the current era. For various reasons, its residents abandoned it around the year 700. The sands of the Sahara soon engulfed the city. It had remained hidden for nearly 1,000 years. Then, in the 1700s, a Scottish explorer started digging out the city. His team first uncovered a sandstone triumphal arch 40 feet high, similar to the ones we can see in Rome and Paris today. An amphitheater soon popped out of the sand, and it was followed by well-preserved statues of Roman emperors. The Scotsman's find was so impressive that no one believed him at first. It took 2 more centuries for archaeologists to fully excavate the city during the 1950s. The site covers a surface as large as 10 polo fields. The ruins reveal the full mastery of Roman city planning. All the streets meet at a right angle in what is known as an orthogonal grid. You can find the same layout in modern cities such as New York. Historians estimate that during its heyday, 10,000 people called Timgad home. Different nationalities lived here, from Romans to people of African descent. Today, more than 2.5 million people live in and around the Sahara. They are spread across 11 countries in total, and their living space is growing. The desert is 10% larger than it was just a century ago. This process doesn't involve sand pouring out of the Sahara. The ecosystems on the edges of the desert simply change over time. The wind blows the soil away and vegetation dwindles. The perfect conditions for the formation of a desert landscape. These changes are happening in the Sahel, a region south of the Sahara Desert. That's why the African countries have recently come together for a project called the Great Green Wall. The primary goal is to stop the desertification of the Sahel and hold back the sands of the Sahara. Their plan is ambitious and involves planting a wall of trees from the west to the east of the African continent. The proposed forest is not only going to be long, but wide as well. The Sahara and the Sahel share a historic bond. Since antiquity, camel caravans have been making the journey from Africa's Mediterranean coast in the north to the savannas in the south. The golden age of this trade kicked off in the 9th century. The perilous journey took several months to complete. The route was 2.5 times longer than the length of the Grand Canyon. Explorers still find evidence of these ancient caravans hidden away under the sands of the Sahara.